So this is our DHT11 sensor components, and it is used to be the temperature and humidity sensor in our circuit. The next one is the ESP8266, in which it will serve as our Wi-Fi module and microcontroller. The last one would be the wires, in which it will connect our DHT11 sensor and the Nodemcu. So now let us try to establish a connection between these components. Let's try to pick up the brown cable, in which we will use this to connect to our ground pin in the DHT11 sensor. The next one is the orange cable, in which we will connect this wire to our VCC pin in the DHT11. And the last one is our red cable, in which we will connect this to our signal or data pin in the DHT11 sensor. And there are some different DHT11 sensor in which the pins are arranged differently. And just like the image from Arduino, the VCC or the pin 1 is on the left part, in which you can see the plus sign there, and it tells us that this pin should be connected to a VCC or a voltage source pin. On the other hand, our data pin and the ground pin is found on the middle and on the right respectively. And you can obviously see the negative sign there, which indicates that it should be a ground connection. And it is way different from our utilized sensor, in which you can obviously see the S sign here, indicating that it is a signal or a data pin, while the VCC is found in the middle and the ground is located beside the negative sign. And going back to our actual circuit, the red indicates the data pin connection, the orange indicates the VCC connection, and the brown indicates the ground connection. And as we are done with the establishing of our connection to our DHT sensor, we are heading to our Node MCU connection. And picking up the red cable, we should try to connect it to our Node MCU's flash pin, and as you can see, should be connected to our flash pin. And it is the data signal from our DHT sensor. This is where we are going to transfer the data to our Wi-Fi module. The orange cable, on the other hand, should be connected to the pin where VCC or the voltage source should be connected. And on the latter part of this video, I will try to show to you the image or the schematic figure where the connection on the Node MCU pins is established. The brown one or the last cable should be connected to the Node MCU's ground pin. And on this image from Random Nerd Tutorials, we can clearly see the details of the pin connections that we had established in our Node MCU. The red wire is connected here in our flash pin, and it is considered also as our data pin connection. The brown wire is connected here to the one of the Node MCU's ground pins. The last one or the orange wire is connected to this pin, in which we can consider this as the VCC connection or our voltage source connection. Overall, this is the pin connections that we had established in our Node MCU Wi-Fi module. And going back to our actual circuit, those are the pin connections that we had established in our DHT11 sensor and Node MCU Wi-Fi module. The only thing that we need to do now is to establish a serial communication from our Wi-Fi module through the COM ports of our PC or laptops with the help of the Arduino code that we had written in our compiler. So for the codes, this is our established written Arduino code in our compiler. And as you can see, we had already uploaded this sketch in our port, which is connected to our Wi-Fi module or the ESP8266. So this is the code in which we are establishing an HTTP request to our database. And as you can see, the values will be sent to the server if we are just looking at the code construction. And as you can see, this is our headers. This is our values, the Wi-Fi name as well. This is our setup for the Wi-Fi connection. And as you can see, we can also see our port here, which is connected to our COM4 or the COM port 4, meaning we already connected our Node MCU module to our PC. And as we try to upload the sketch, the connection was successful, meaning we can monitor it in our serial monitor. And as you can see that the values that the DHT sensors detected has been displayed and is communicated through our serial monitors. So let's try to take a look in our graphs and charts for us to monitor if the values are coming in. And take note, every 15 seconds the values should register in our serial monitor and as well as to our designs or our graphs, charts, and gauges. And as you can see, the values that has been displayed in the serial monitor is registering in our database, in our designs, specifically in our numerical display and as well as in our gauge meters. The only disadvantage for this established communication is that there might be the slow internet connection for our Wi-Fi, which can affect the information that has been transferred by the serial monitor to our database. For an instance, when a serial monitor displays a value, it can't be or it can be read by our server. However, there are some values that the server skips, meaning when two serial information has been displayed by our serial monitor, our server ignores those skipped information because of the internet connection. Fortunately, this information is still stored in our database, and when you download the Excel file, the information is still there. The only thing that making it disadvantageous is that the displays or our display data such as the line graph, bar graph, gauge meter wasn't able to display the sensor data at exact time it has been registered because of the slow internet connection. And as you can see, the values are still changing, meaning the values from our serial monitor is still registering in our UI or our web server, in which line graph, gauge meter, bar graphs, or our histograms is created. And I guess that would be all for our graphs. And as we try to scroll up, we can see here our number of entries. We can also see the last entry, which is updated about a minute ago. And then we can also see the time creation of this database, and we can also see the export recent data here. This will enable us to see and manage all of the informations that we had detected from our sensor data by just downloading the Excel file. And as you can see, on the first column, we can see the timestamp of each data transmitted from our data sensors. And from the second column, we can see the ID number or the entry number of each data transmitted from our serial monitor to our database. And the third column is the readings from our temperature. And for the fourth column is the readings for our humidity. And take note that the fifth and the sixth column is just the same with the readings from our columns 3 and 4. They are both the same for our temperature and humidity sensors. And we guess that would be it. Thank you for listening and taking time to look for this video. Thank you very much in behalf of my group mates. God bless and keep safe everyone.